that region, 1 over x squared plus 1, is not bounded. So if I'm asked to find an area, I am asked to find an area from negative infinity to infinity. And so that looks like it's impossible. But if you type this in your TI-89, it tells you the answer is 5. Does it say 5? So it's saying the area under that region is the number 5, which you should find slightly surprising because we just found the area of an infinite region, which should be a little, wow, we can do that, right? That's weird. And then number 2 has a vertical asymptote at 0. So that should be a problem, right? And if you tried to do it by hand, you would get a problem, wouldn't you? Because you would get some issue with the x to the 1/3. So, however, do you get an answer when you type that in your calculator? What do you get? So today we're going to figure out where in the world your calculator got those numbers. That's going to be our goal for the day, is to figure out how to solve what's called an improper integral, which is an integral involving an infinite piece, whether that's an infinite endpoint or infinity at a vertical asymptote. So we're going to look at both of those cases. These are examples of improper integrals, and then also an integral with a discontinuity is also called an improper integral. To evaluate these, we're going to rewrite the integral as a proper integral using limits. So that's going to be our goal for the day. We will revisit those 2 bell ringer problems. They are examples later in my slideshow that we will look at how to get those answers by hand. Or they are, one of their endpoints is at an asymptote, or if there's an asymptote involved in general. We've actually seen a couple of these come up on some multiple choice problems we've done, but all the ones that we've seen had no answer. And we said no solution. We actually use a word called divergent. We're going to learn a little bit more about what that means today. Okay, so I'm going to look at this one first. The integral from 1 to infinity of 1 over x dx. Step 1, I can't work an integral with an infinity in it. So the first thing I'm going to do is rewrite it as the limit, and I'm going to pick a letter, whatever letter you feel like picking. I'm going to call it b. As b approaches infinity, the integral from 1 to b of 1 over x dx. So we've taken an improper integral and made it into an integral that we can work, and then in our final answer, we will have a limit involved, and we'll find that limit using our limit rules. Can I anti-differentiate 1 over x? What is the antiderivative of that? Good. Natural log of the absolute value of x from 1 to b. On AP open response, your work needs to look like this. They need to see the limit. Don't just leave the infinity in the integral that you're working in. And so I get the limit as b approaches infinity of the natural log of the absolute value of b minus the natural log of 1. I know the natural log of 1 is 0. Did you all know that? Memorize that. I think it's been on the game. Because anything to the 0 power is 1. That's why that's my natural log. So my question is, what's the limit as b approaches approaches infinity of natural log. What's natural log do as x approaches infinity? Does it level out though?
No.
No. So it goes to infinity, doesn't it? Very slowly goes to infinity. So this integral has no answer. It's called divergent. It diverges. It does not have a finite area like the two on the bell ringer did. If you were to type this in your calculator would have said the answer was infinity. Because it doesn't converge to one number. It doesn't give you an answer. That one diverges. We would think that they would all do that. Right? So you're going to see later some examples that don't do that. And it all comes from this one. Okay, so let's look at the next one. Before I work it, you tell me how to rewrite it. This one up here. But you're right. We'll do that one too. You're fine. How will I rewrite that? Okay, the limit is b approaches infinity, and you can use any letter you want. There's nothing fancy about b. The integral from 1 to b, e to the negative x dx. Any questions so far? Can I antidifferentiate e to the negative x? And what is the antiderivative of e to the negative x? From 1 to b, not doing the limit as e approaches. I'm going to plug in b, I'm going to plug in 1. Negative e to the negative b minus negative e to the negative 1. Am I going too fast on that part? Everyone know where I'm getting that? Negative e to the negative 1, actually it's plus because two negatives. I just get 1 over e, right? And this is negative 1 over e to the b power. Does everyone agree with that? And as b approaches infinity, what does negative 1 over e to the b do?
It goes almost to 0.
The limit would be 0, right? Because as e to the b gets bigger and bigger and bigger, 1 divided by that gets smaller and smaller. So this piece goes to 0. So this is just 1 over e. If you would have typed that integral into your calculator, it would have told you that the integral was 1 over e. So this one we were able to do. It's called a convergent answer. It converges to the value 1 over e. So this infinite integral has a finite answer. Strange. True. Any questions about that one? You try the third one on this page. Let's see. Anyone tell me what is the setup?
You change the infinity to a character.
Good. Change the negative infinity to an A or B or whatever. You can call it whatever you want to. Typically, a textbook's going to call the bottom one an A and the top one B. But you don't have to do that. It makes no difference as long as you call it something. If you aren't careful, then you need a U substitution for this problem. Does everyone agree?
It's over 1 over 4.
Good. Now, if you can do that without doing a U substitution, I'm okay with that, but don't just put down e to the x over 4. Does everyone know what I mean by that? That is not the antiderivative of e to the x over 4. If you did a U substitution, you got 4e to the x over 4. Does everyone agree with that? If you can do that without a U substitution, that's great. But don't pretend you can do it without a U substitution and get it wrong. I don't know what I mean by that. So the limit as a approaches negative infinity from a to 0. If I plug in 0, what's e to the 0 power? 1. So I get 4 minus 4e to the a over 4. Okay, and now what happens? I plug in what the negative infinity would do. I take the limit as x approaches negative infinity. What happens to the e to the a over 4 when I plug in numbers? Really, really big negative numbers. Goes to 0 because it flips it that negative infinity, makes it 1 over. Does everyone agree? 1 over infinity. So this piece goes to 0. The answer is 4. Questions about that one? It is. It is very much limited. Mixed with some liberals. Okay, so this one's the bell ring. You already kind of figured out how to set this one up in the bell ringer. If you look at the region, it looks something like this. Okay. And so to find the area of the region in the first and second quadrant, we end up with the integral from negative infinity to infinity. When you have an infinity on both sides of the integral, you actually have to split it into 2 integrals. You can stop at any point you want, but you do have to split it into 2 integrals. So I'm going to split this into the integral from negative infinity to 0 plus the integral from 0 to infinity. From our properties of integrals, is that an equivalent integral? You could pick anything. 0 is a nice number for tan inverse, which you already said this is a tan inverse integral. I know the value of tan inverse at 0 from my unit circle, so it's a good choice. You could pick something else, but this one makes for nice numbers. So now I have 2 separate limits. I have the limit. B approaches negative infinity from b to 0. And I also have the limit as a approaches infinity. Yes. Did anyone not end up with an extra? Sure. Peyton, did you? When you have 2 infinities. Because how else would you write them? lie when you must. Stand for that. Tan inverse. I only have to do the antiderivative once, even though I have to write it twice. Same antiderivative. Now, these could be any integrals that you have faced so far. You could end up with one where you have to do partial fractions. You could end up with one where you have to do parts. Any integrals that you've done are fair game. We just now have this limit piece at the end. I told you you knew how to do tan inverse of 0. Do you know the tan inverse of 0? 0. What's the value of tangent at 0? And it is 0. So I get 0 plus the tangent inverse of b. The limit as b approaches negative infinity. Plus the limit as a approaches infinity of tan inverse of a. We do have to have a little bit of knowledge of tan. By the way, that's minus 0. That should be minus. We do have to have a little knowledge of the graph of tan inverse. What happens to tan inverse as x goes to infinity? Just remember. As x goes to infinity, what happens to tan inverse?
It is because it's on its side like this.
Okay, so it's a normal tangent graph. A normal tangent graph, where are the asymptotes on the tangent graph? Pi over 2 and negative pi over 2, right? So the tan inverse graph is that flipped over. So where are the horizontal asymptotes on tan inverse? Pi over 2 and negative pi over 2. So the limit as b approaches negative infinity on tan inverse is negative pi over 2. Because that piece that goes to negative infinity. So this is negative pi over 2. And as x approaches infinity, tangent goes to pi over 2. Because again, it's a tangent graph flipped over. So last year when I made you do those master exams and you wondered why I made you know how to graph trig functions, it's not because you have to do it that often. It's because you have to know what they look like. Negative pi over 2 makes positive pi over 2. Pi over 2 plus pi over 2 is pi. Is that what we got in the bell ringer? No, but we're close. Okay, your homework, 2-day assignment. You have a worksheet and 2:30 even on page 471. Those are both due on Wednesday. No, today's Tuesday, isn't it? But okay, on Wednesday. Oh, that's sad. So both of those are due on Wednesday. Bookwork and multiple choice worksheet will harbor multiple choice. We will finish the notes tomorrow, but you have a really good start. Thanks.